And map takes a function, calls that function on every element of the list, and produces true if and only if that function produced true every time. So a board that's full, a board that's solved, is a board where every element is a number. No element is false. So that's just this. Let's try running it. Oops, forgot to comment out that stub too. Two tests fail. Those tests, I think, I hope, are tests on, these are tests on, see the boards are big, so they print out kind of big. These are tests here. Those two tests are failing. But our tests on solved are passing. So solved is done. Solved was easy. Solved was just an and map of number over the board. Okay, now let's work on next boards. Now we're going to suffer here a little bit because boards are big. They're 81 elements long. So that's going to be a little bit annoying when we construct the tests. I think we can manage to do it anyways. What we need to do is we find the first empty square, we fill it, we make 9 boards with 1 through 9 in that empty square, and then we keep only the valid ones. So what I'm going to do here is I'm going to write a check expect. And the board I'm going to use is going to be cons of 1 onto rest of board 1. Board 1, if you recall, is the empty board. Board 1 is an empty board. So what I'm saying here is I'm saying make a board. You'd never see this board in a game in the newspaper. But I'm saying make a board that has a 1 in the upper left corner and everything else is empty. And now I need to make the result. Well, let's see. The result is going to be a list of boards. And, you know, we can kind of see what it's going to be. It's not going to be that board because that board's invalid, right? Once we've got the 1 there, we're not going to have another 1. But it's basically going to be the board 1, 2, and everything else is blank. List 1, 3, and everything else is blank. And it's going to be those 8 boards. 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Now, how am I going to write this dot, dot, dot? How am I going to write this? Well, these dots are kind of really something like rest of board 1. Okay? Except I can't say list like this. I need to say cons 1 onto cons 2 onto rest of board 1. So I take the first 2 squares off the board and I replace them with 1 and 2. So all these things here that I typed aren't quite right. I was doing them to sort of see what it would look like. I'll just replace them now with, let's see, that's a 3 and that's a 4 and that's a 5 and yeah, this is a little tedious. But remember, the more complicated the functions are, the more it's worth really having thought through what they're going to do. That's check expects as examples. And the more it's worth having good tests. That's check expect as tests. So that if we don't get this right, we'll know about it. Put it this way. If you've got next boards wrong, then there's no way solve is going to work, right? And it's going to be hard debugging solve if the real problem is in next boards. So even though these tests were a bit cumbersome to make, they were worth making. And I think actually that's going to be enough in this case. I could make some more complicated cases, but I think we'll be able to test the helpers to do that. And the reason I think that is look at this purpose. We find the first empty square. We fill that with natural 1 to 9, and we keep only the valid boards. How are we going to template this? To me, it templates as a function composition. Starting with the board, we're going to do 3 distinct things, 3 transformations of what we get to get the result. So I'm going to template this as define next boards of board. I'm going to template it this way. I'm going to start with find the first blank of board. And once I've got that blank, I'm going to say fill with 1 to 9 the blank spot on the board. So this first thing, find blank, gets me the blank spot. This next thing says, hey, in this board, fill the blank spot with 1 to 9. So this first thing produces a single pause. This second thing produces a list of 9 boards. And I'm going to say keep only valid of that. And that last thing produces up to 9 boards. I'm templating it as a composition. To understand the function composition, probably the best thing to do now is do the wish list entries. So let's see, find blank, it consumes a board and it produces a pause or a position, and it produces the position of the first blank square. And one thing that makes this function's job a little easier is we're only going to call it on boards that we know aren't full. Because if you go back here, first we ask, hey, is the board solved? And only if the board is not solved, in other words, if it's not full, do we call next boards. So this function can assume the board has at least one blank square. Define, it's a wish list entry. Find blank of board, and we need to produce a position, so let's just say 0 stub. So that's our wish list entry for find blank. Here's our wish list entry for fill with 1 to 9. Let's see, its first argument is going to be a pause, and its second argument is going to be a board, and it's going to produce, it has to produce a list of board. We want to take the board and the blank and produce one board for the filling of the blank with 1, and a board for the filling of the blank with 2, and a board for filling of the blank with 3, and so on, ... Produce 9 boards with blank filled with natural 1 to 9. It's a wish list entry. And finally, keep only valid. Well, keep only valid consumes a list of board, and it produces a list of board. Produce list containing only valid boards. It's a wish list entry, and there's the stub. LOBD is empty. I didn't mark this as a stub, although it obviously was one, and I didn't mark this as a stub. Let's see, if we run, we'll see if all the stubs and things are well formed. What happened there? Oh, I forgot to comment out the stub for next boards. Fill with 1 to 9 expects only one argument. Oh yeah, I forgot to give fill. I put 2 in the signature, but I only put 1 in the stub. So we'll say, let's see which argument comes first. The position comes first and then the board. So let's see, we'll just call the position parameter P. Great. Now we've got some failing tests, which isn't so surprising, but things seem to be well formed. You know, it's kind of 1 step forward, 2 steps back here. We had a wish list entry for solved, and we were able to finish solved, so that was great. But we also had a wish list entry for next boards, and when we designed next boards, we ended up with 3 more wish list entries. Let's hope at some point they start actually resolving.